Hi, everybody. My name is Anthony Jones. I'm a senior here at Texas Tech University in Lubbock, Texas. This project that we're looking at right now is a project for Dr. Tanner's Capstone course in the Integrative Studies Department here at Tech. The title of this paper, Desalinate the Land, is an examination into the feasibility of desalinated water use as a subsidiary to freshwater use within the Texas agriculture industry. I know it kind of sounds like a mouthful, but we will essentially be looking into desalination, which, if you don't know, is the process seawater is transformed or processed into viable fresh water for various industrial reasons. But that's essentially what we'll be looking at in this paper: is if it has potential to supply water to the Texas agriculture industry. To begin, I would just like to emphasize kind of the importance of water, not only towards this subject, but in general. Water is one of the main sustaining factors for life. The human body is comprised mainly of water, just as a pure reference point that just kind of surrounds the importance of it. But beyond that, water plays a major role in food production and just kind of in everything that maintains life that we consider water a viable option for. I chose this topic in particular because of its complexity and kind of its influential resolve about it. The results of the water issue in general will inevitably play a role in all of our lives, as water plays a role in all of our lives. Agriculture, on the other hand, was chosen for this particular study because agriculture is consistently the number one industry, the user of water, freshwater resources at least. That's kind of the reason we're trying to focus in on the biggest users of water, at least for this study. And Texas was chosen particularly not only because it is the city to which this study was taking place, but also because Texas shares a border not only with an oceanic area, but with an arid region, and Texas is also one of the largest commercial crop producers in the United States. An interdisciplinary approach was taken to this specific issue because of the sheer complexity of the issue. REPCO, particularly his interdisciplinary approach, his 10-step program, was used to kind of dissect this issue as a whole. But also because by using his approach, we're able to look into the varying influences that actually are at play within the issue. Because this issue is so complex, it has a multitude of different disciplines kind of at play within the situation. So with REPCO's approach, we're able to kind of hone in on the specific areas that we're trying to focus on, which allows us to get the viewpoints from those areas, which kind of gives us a better understanding of the problem at hand. One of his first procedures in this 10-step interdisciplinary approach is to identify the relevant disciplines within your problem or your issue at hand. I have identified a few that kind of apply to the water issue in agriculture, but specifically towards the desalination side of this issue. First off was obviously agriculture because of the sheer influence that it plays in the problem. Because we are looking specifically at agriculture, it kind of plays hand in hand with the issue. The disciplines that go along with agriculture, plant soil science, plant physiology, all things that have to do with the actual of plants and kind of the chemical and physical constituents needed for this to be a viable process. Engineering was also viewed as a relevant discipline from the desalination standpoint because desalination traditionally has been a fairly inefficient process. There have been new technologies and innovations within the engineering field that have allowed for desalination to become a more efficient process, a more productive process, and one that produces less hazardous waste because traditionally desalination processes have had a side to them uh, that causes hazardous waste, which is kind of the big argument against them for the whole part. Next considered was the environmental science discipline, sheerly because it looks at kind of the impacts that desalination could have on the environment around not only desalination plants themselves, but also uh, the places where the desalinized water is being applied. Sometimes there are different variations within plant nutrient levels because of varying water toxicity levels, things like that. So that could also have an effect on the issue. Economics could definitely be considered as a discipline to this issue because of the sheer amount of dollar amounts that could be applied to the problem. But in the end, if the economic impact is still detrimental and the dollar amounts are still too excessive to make this process work, then it wouldn't be a viable process. So economics always kind of has a play in new development and new technology. And even the sociology discipline would be considered here because you have to consider people's personal opinions on the issue at hand. Some people aren't comfortable with the use of desalinized ocean water on their crops or even in their livestock. So people's opinion will always play a major role, in fact, in issues like this. From identifying just kind of the relevant disciplines to your issue, we can narrow it down to the most relevant that actually apply to our specific issue, which is potential for desalinized water on crops here in Texas or agriculture industries applications here in Texas. So I've narrowed down the most relevant disciplines to this issue is the agricultural science discipline, which kind of gives you the standpoint of an agriculture disciplinary perspective, more on their side, but still in the issue at hand. Also engineering, which kind of looks into the processes that are involved with desalination. It also looks into the efficiency and potential for implementation strategies to make this possible. Not only would the water have to be desalinized, but it would also have to be transported and applied to these agriculture areas in a way that's efficient enough to make the process feasible. The next step in this process was to do the literature review, which kind of gives you a background of your different disciplines and kind of perspectives and theories that come out of those disciplines, at least in regards to this subject. In regards to engineering, there was quite a bit of qualitative reports and figures that showed things like improvements and just basic improvements within the technologies surrounding the desalination processes, and even improvements within the methods of disposal of kind of the byproduct that comes with desalination. So it just shows kind of an improvement in the general systems that go along with desalination. With that, the agriculture side showed kind of more of a qualitative response. It gave a little bit more emphasis to the fact that agriculture is actively seeking a solution to this long-term problem that we face of eventually we are going to run out of water. I say freshwater resources, and at some point we're going to have to find a way to supplement that with another form of fresh water. And the current question is, where are we going to kind of find this other form of fresh water? This is kind of where the solution comes in, or the issue and solution come into play here. The common ground can be made that the situation, while desalinized processes and implementation can have initial effects, the ultimate response for many agriculturists when it comes to the subject is, where else is the water going to come from when the well runs dry? This has always been kind of the case, and it's always the overhead thought with this subject, which is kind of where the desalinization processes come into play. They offer a solution to the agricultural issues that are being faced, at least in the Texas agriculture industry, as well as offering a solution from the engineering side of it, which is providing increasingly advancing technology on the subject and making the systems more efficient and more accessible to just say the individual farmer or even the farming co-op that's taking place here. Whoever's using this water source, it's becoming more efficient for them, and in the end it will play a huge role in the reestablishment of our freshwater resources, because we are using less of them now, or we would be using less of them with this new process. We would be able to replenish the underground resources through natural processes more quickly than we would be now. The conclusions to kind of be made here were that in this issue that we're facing, looking for potential uses of desalinized water within the Texas agriculture industry, there are multiple disciplines facing varying aspects, varying opposition from each other. But in this instance, the two disciplines involved, agriculture and engineering, can offer a solution for each other. That's kind of the conclusion to be had here, is that the disciplines, while opposed sometimes in theory, can assist each other in assisting new goals and kind of forming new insights and concepts. So because the Texas agriculture industry is avidly seeking a solution to an age-old problem of where we're going to get the water to grow crops when the freshwater resources run out. Engineering's the answer, and not a new process, but a improving process in desalinization. This is influential on a couple of scales. On a local scale, it could be influential. It could be influential because it provides provides kind of an insurance to farmers that they have a constant supply of water, that they're not going to run out on just this random day, and they're not going to have any supplemental water for that. But on a national level, it could be influential in that if this was to actually take play on a grander scheme, that it could potentially revive the freshwater resources that we have so abundantly overused throughout our history, which could have a huge benefit to later generations who avidly need the water as well. Testing the results. This study was never intended to have real-life simulation tests done to it. Instead, it was meant to be more of a base of knowledge for further testing. I believe this would be a great base of knowledge for further testing in any kind of agricultural sense, and long-term efficiency to things like plant soil efficiency, and the ways that this could be positive or detrimental to plant nature and things like that. But the end, and thank y'all, Rec and Tech.